Hey, Dr. McVaugh. I was working on trying to figure out how to do a histogram, and I think I did figure out how to do it. So I'm just going to quick show you how I did it. So, in case it's hard to figure out, maybe this is what you're looking for. So here I just have my data right here, running on the side. And this is numbers, so I don't know how a Windows program would run, per se, but they're fairly similar. So I'm just going to convert to millivolts. I think I did that correctly. And I already have them sorted based on their how much voltage was given off. So I don't think that really matters how you do it this way, but it makes it easier to see at least. Just go to the bottom. So there's that. So now that we have them organized, what you have to do is you have to create an interval period. So here it's starting at 1100. So if I start at negative 1000 as like the lower end of my x-axis is what this will be, and then just I would think going up by 100 increments will do that, because that's pretty much where they are. They're only every 100 increment. So once you put in a couple, then you can add the rest of them in. So this is basically creating the y-axis. Now there's more on here than I need, just because of how, oh sorry, I don't need to go that far. Oh, one thing, I have to figure out how many I need. I need to, say 1,000 will be all I need. Switch here. So there's that, and once you see the histogram, it'll make more sense. Then this row just becomes an index. So you just literally label them 1, 2, 3, and you continue for the rest of the column. And this is basically just creating a category for the program that you're going to use. So then now is when you actually do the calculation. So in here, equals, and then index, parenthesis, followed by frequency, another parenthesis. So then you insert your data. So I'm going to quick grab all of my data here. So this is going to be what the raw data it's going to be looking at when we do this calculation. So once you have it, you have to make sure that it's column locked, so it only takes these. You have to set the $sign in front of the C and in front of the 2, and you do that for both things. So it's absolute row and column, so the column and row will not change as I do the calculation. They will always stay in this column. Then we will follow it by a comma, and then now we're going to input the category. This is basically, this is the unit it's going to go by. So this is luckily smaller, it takes a little less time. And then this again also has to be column locked. So you just, numbers does it this way where you can do the drop down. This one's a little easier. You can do it like this, or you can just put $signs in front of it too. That works. So then we're going to close parentheses and put a comma, and then we just have to put the first like category or area it's going to put it into, and that's all you gotta need. And you don't need to column lock that, because that's going to change the calculation. Just dragged and dropped. Then we close the parenthesis and we hit enter. So there's no spikes at the 1000 level. So now we can drag this down to basically form, and you can kind of see at the tail end there's really not many spikes. There's 5 here. So we'll see what it looks like, and then this is what we're actually going to plot, this right here. So you can just select the whole row, and then go to chart, and then just do a bar graph. And so here we have it here, and you can see that it's not labeled. Again, I don't really necessarily know how Windows computer is going to do this, but you can select the labels and then drag through this and label it according. So this will just label it based on what category it's in. Alright. Sorry, this is slow and painstaking, but Hopefully it'll work when I get it to the bottom. So there is the final 90. Sorry, I gotta edit that. So it's just here. Alright, that should be fine. Alright, so now these are labeled. I'm not entirely sure why it's so small. Oh, I know what I did wrong. Sorry about that. I selected the wrong column row. I put too many. So let me just scroll up here. Sorry, this is taking a while. There we go. So now this should look better. Yes. So now this histogram is labeled. I don't know how much is going on out here. There's not a lot of clear evidence. So when I did my final one, I cut it off at about the 1500 because it didn't show, like, as you can see here, it's kind of, there's some spikes, but there's not a lot going on. There's not a clear, distinct, like, oh, here's a clustering here. So I don't know exactly how you want them, but then once you have the table like this, you can label the axes, and then to make, sorry about that, to make the histogram look like it, you put the gap between the bars as 0, and it will then fill it in like a histogram. This is the closest thing I've found to exactly like close up to a histogram if you're doing some research and figuring out how to do it on a numbers program. So I hope this helps, and I'll print out both of my charts. I have this for the histogram of the tail stimulation. So the main peak is at about like in the 4,000 for millivolts, and then for the other one of the baseline, it's in about the 3,000. So you can see the shift of it. So I hope this helps, and I hope this will help other students figure out how to do the histogram. So thanks, Dr. McFaw, and I'll see you tomorrow morning.